Okay, so good afternoon, everybody. Now we are starting our second part of the first lecture. We shall make a review of what we discussed yesterday regarding the mechanical properties of steel. As we said that steel is one among the three products of iron ore. The others we say they are cast iron and wrought iron. So our interest or our concern will be on the steel, of which we said some people are still joining, sorry. So we said this one is can be used as plates, sections, as well as bars. So these are three products from the steel mills. Now from the three products, then we can fabricate beams, girders, columns, struts, ties, among others. Again, we said that we can differentiate steel with the other types of cast iron products by considering the amount of carbon in that particular material. And we said that the higher the carbon content, the higher the shear strength and hardness, but the lower ductility and the toughness. So if a steel contains high carbon content, it will lead it to having high shear strength and it will become more hard. However, it will not be more ductile. That means it cannot be stretched easily, as well as it cannot withstand toughness. So from the screen, I think you can see here, on the left-hand column here, we have the composition in terms of carbon content. So our concern is here. This means that steel contains carbon content ranges between 0.25 and 4%. That is the midway. Okay. And the melting point of steel is about 1300 up to 1400 degrees Celsius. It is the mid between the two. Here you can see it is 1200. For the wrought iron is 1500. So this one ranges between 1300 and 1400 degrees Celsius. With respect to hardness, I think you can see here, that means the higher the carbon content, the material becomes more hard. Okay? The lower carbon content, see this one cannot be hardened or tapered. And this one, because it's the midway that contains an average quantity of carbon, then this one can be hardened as well as can be tapered. With respect to strength, that is one of the very important mechanical property of steel. You can see here the compression strength for the cast iron ranges between 6.1 up to 7.1 tons per square centimeters. You see, very strong. It can withstand the stresses up to 7.1 tons for each square centimeters. Very, very, very strong, this one. But this one, you can see, the compressive stress ranges between 4.75 up to 25.2 tons per square centimeters. And the ultimate tensile strength, so this is the compression strength, this one is the tension strength. This one ranges between 5.51 up to 11.02 tons per square centimeters. Here it should be centimeters. Okay. So I think with respect to rusting, you see, cast iron does not rust. See? Why? Because of the carbon content. So this one rusts easily. This one rusts more than cast iron. But this one rusts very easily. And as you remember yesterday, we said that when you work with the steel, you have also to ensure the proper precautions to prevent rust, because steel gets rust easily. If we look on another property, that is malleability and ductility, you'll see that cast iron that contains high carbon content, it is very brittle. However, cast iron cannot be welded or cannot be rolled into sheets. It cannot be formed into sheets because it contains high carbon content, and therefore it becomes very brittle. That is cast iron. With respect to wrought iron, this one is tough because of steel. It has high carbon content compared to the third product. But because it has low carbon content as compared to cast iron, then at least it is moderately elastic. It is moderately ductile. But still, with the average carbon content, then this one is tough. Then it is malleable, that is, can be formed into other shapes. And it is also ductile. See? Now, if we consider reaction to sudden shocks, you will find that steel absorbs shocks. With respect to forging and welding, these are mechanical processing, you will find that steel can rapidly be forged or it can easily be welded. However, cast iron still is brittle and cannot be welded or cannot be rolled into shapes. So from these properties regarding composition with respect to carbon content and other mechanical properties, I think now we can see, or we can reach at a point of understanding why steel is used as structural elements as compared to other materials. So you can see here, subject to those properties that we have mentioned them, then steel can be used as reinforcement in both pre-stressed concrete and in normal reinforced concrete. Steel also can be used to form structural members like beams, columns, purlins, among others, those we mentioned yesterday. Also, the same steel can be used to produce bolts for connecting structural steel members and the other uses. Also, steel it can be used to form sheets. I think you can see the roofing sheets, for example, which are plain or corrugated. Okay. So as well as they can be used in making various machine tools. So there are some of the uses of steel. And our concern in particular, it will be here. We shall deal with the use of steel as structural members and the connections, especially bolts. So again, if we go now to the subgroup of steel, then we may have a range of steel types depending on the amount of carbon. See? So one, we have the so-called dead mild steel. Dead mild steel, this is the one with carbon content not exceeding 0.15%. Okay? Then you have the mild steel. This one is the moderate, 0.15% up to 0.3% of the carbon content. Then you have the medium carbon steel, which ranges with the carbon content from 0.3 up to 0.8. Then you have high carbon steel, that is above 0.8, but not exceeding 0.15% of the same carbon content. Finally, we have the cast steel or carbon tool steel. This is the one that contains carbon content of which its quantity is greater than 1.5%. See? So there are 5 classifications of steel with respect to carbon content. Any question to that point? Okay. So our concern, as I said, it is on the mild steel here. That is our concern. Now, one of the properties of the mild steels is its ductility and malleability. That is, it can easily be forged and it can easily be stretched into other forms. As compared to cast iron and wrought iron, this one is prone to rust, but it is more tough and more elastic. And because of the carbon content that it has, it corrodes very quickly. You say, but you can forge it easily and you can weld it. Again, we said it can withstand shocks and impacts. Further, it does not affected highly by saline water. Saline water, for example, that is seawater, the one that contains high amount of salt. With respect to tension strength, as well as compression strength, we say it has almost equal strength in tension, compression, as well as in shear. With respect to specific gravity, you see that it's about 7.8. So this means that the density now of steel is about 78 kilonewton per cubic meters. See, that is the density. Specific gravity is 7.8, but the density will be 78 kilonewton per cubic meters. Now the uses. As we said, steel can be used as rolled structural sections. So these rolled sections, they're special sections that are manufactured according to the shape at the factory. So in factories, we'll find such sections having shapes like I section, T section, channel sections, as well as angles. We also have the plates. We have the round and square rods, as well as the normal mild steel round bars. See? Again, we also have the reinforcing bars, the ones that are used in normal reinforced concrete structures, as well as the pre-stressed concrete. But also, we have the tubes, the mild steel tubes, or hollow sections, the sections that contains holes, like pipes. So we have the mild steel tubes. Also, we have the plain, as well as the corrugated sheets, which are normally used for roofing purposes. So these are some of the uses of the steel, of course, including the bolts and the nuts. All those are made from steel. So, of course, our interest is not on high carbon content steel. I will go straight to this one. I want to introduce you the alloy steels. So this one, it is steel which contains some other elements for the purpose of increasing strength, hardness, toughness, as well as the resistance against corrosion. And sometimes resistance against thermal as well as electrical conductivity. So you can improve the normal steel by adding some elements on it, and by so doing, we no longer having the normal steel or the mild steel. Instead, we shall have the so-called alloy steel. So an alloy steel is a steel material which contains some more other materials that has been added to the parent steel for the purpose of modifying some mechanical properties. Such properties include strength, hardness, toughness, resistance against corrosion, as well as thermal and electrical conductivity. Are you okay on that definition, all of you?
May you repeat, sir?
Yes, I'm saying that an alloy steel is the type of steel in which the normal mild steel has been added with other elements for the purpose of improving its mechanical properties. Yeah? And I said that such properties, which can be modified, includes strength, hardness, toughness, resistance against corrosion, as well as to improve thermal and electrical conductivities of now the new formed materials. So such a material is what we call an alloy steel. Okay? So the alloy steels have been now divided into two categories. One is called the ferrous alloys. So this one is the one which contains chromium, nickel, vanadium, and others. And the second group is what we call the stainless steel. Okay. So, in fact, an alloy steel, you'll find it is more expensive as compared to the mild steel because of its composition. And now, with respect to stainless steel, for example, this is not used as a structural materials. But it has the following main properties, like it is very hard and strong. It is a good conductor for heat and electricity. It is more ductile. It retains its strength and cutting edge regardless of the temperature. So stainless steel is one of the strong properties, strong steel, but it is not used for structural materials because it is very, very, very expensive compared to the mild steel. So the summary of that, of which we have discussed, we are talking about the normal mild steel. If we are looking on the graph, this one has been derived from Hooke's law. So here we have stress, here we have strain. Okay. Remember, stress is the ratio between applied force over the cross-section area of the element, and the strain, this now is the ratio between stress and the Young modulus. I think you remember from Hooke's law. So strain here stands for deformation or defined deformation. And here, stress, this one implies the effective load per square meter or the cross-section of this particular element. So we have several ranges when steel is loaded. Here we have 4 ranges. So the first range, this one, is what we call the elastic range. It's during elastic range, in this case, the material is still elastic. That means when the stress is proportional to strain, or the stress is proportional to deformation. And once the load is released, then the material will go back to its original form. That is, deformation is not permanent. This means that it's the elastic range, deformation is not permanent. But up to this point, which is called the yield point, although the load will remain constant, but still the material can deform, can undergo some deformation. So at this range is what we call plastic range. And at this point, although you can remove the load, but still deformation will occur. And the material is not able to return to its original position or to its original shape. So the material remains to its deformed shape, regardless of the load that has been reduced. So this one, from 1 to 2, is what we call plastic range. However, if again you increase the load at this point, you will see that we have also more deformation while you increase the load to a certain point up to stage or up to level 3, this one. So this one is what we call the strain hardening. So at this point, your material now will harden due to excessive strain. So it can withstand a certain load up to a certain ultimate limit. Up to a certain ultimate limit,